We've spent some time looking at direct variation and inverse variation. Now we're going to look at combined and joint variation. The good thing is that it just takes those two things we already know and puts them into one problem. So if we recall, direct variation dealt with y equals k times x. And inverse variation was y equals k divided by x. I'm going to fix my dvx. So when we look at these other two types, we're just going to combine these two. So combined is literally when you have dv, direct variation, and iv, inverse variation. So we have them in the same problem. And joint happens when a variable varies directly with more than one thing. So an example might be y varies directly with x and z. So let's look at a couple of problems where we combine everything together. What's nice is that a lot of the things that worked for direct variation and inverse variation just carry over to these types. So the variable m varies directly as t and inversely as w. So this is a problem that is a combined variation. The variable m varies directly as t and inversely as w. So m equals kt over w. There's just one k in every problem. Makes things a little bit simpler. It says if m is 24 when t is 3 and w is 2, we can plug that into our equation to find our constant. So m is 24 when t is 3 and w is 2. Now we just have an equation we can solve. To get that 2 out of the denominator, we would multiply. So 48 equals k times 3. Now we just need to divide and we'll find our k. Divided by 3, so k is 16. Now we can write our equation that's more specific. M equals 16t over w, because it's varying inversely as w. With this specific equation, we can finish answering the question. The final part of the question says we want to find m when t is 5 and w is 8. Well, let's just plug it into all this stuff we already know. M equals 16 times 5 divided by 8. So m equals 16 times 5, which is 80, divided by 8. So m equals 10. Now let's look at the volume of a rectangular prism. This is something you should be familiar with. The volume of a rectangular prism varies jointly as the length and the width. So if we recall, joint means it varies directly as two things. So in this case, volume equals k times length and width. So it says that the volume is 224 cubic feet when the length is 8 and the width is 4. So 224 equals k times 8 times 4. So now we can just simplify and we can find k. 224 equals k times 32. So divided both sides by 32 and we're going to get k equals 7. So our specific equation for this problem is volume equals 7 times length times width. So this is a particular rectangular prism that has a height of 7. Now we're going to change a couple of things about our problem, and we are going to find the length of when the volume is, let's see, 210 cubic feet and the width is 5. So we changed those numbers and we need to find the new volume. So the volume is 210 and that equals 7 times the length times 5, which is the width. So we can multiply those two things that we already know. We know 7 times 5 times length. So let's say 210 equals 7 times 5, which is 35, times the length. Now we just need to divide and we'll find the length. So we'll divide both sides by 35 and we'll be able to find our length. 210 divided by 35 is 6, so the length of this particular prism is 6, feet, since that's the units we're dealing with. So now we've seen combined and we've seen joint. Not a lot of differences, except we have to plug in more numbers in order to find our constant. The volume of a gas varies inversely as the pressure and directly as the temperature. So this is a combined problem. It varies inversely as the pressure, which means we're going to have divided by pressure, and directly as the temperature. So temperature will be in the numerator. So volume varies inversely as pressure and directly as temperature. So a certain gas has a volume of 10 liters, temperature of 300 kelvins, and a pressure of 1.5 atmospheres. That's the specific problem that'll help us find K. Volume is 10 equals K times temperature, 300 kelvins, divided by 1.5, which is that pressure. So if we want to find K, first thing we're going to need to do is multiply both sides by 1.5. So 15 equals K times 300. Now we can just divide both sides by 300 and we'll get our constant in this problem. So our constant, 15 divided by 300, is 0.05. So now that we have this constant, we can write our particular equation. Volume equals 0.05 times temperature divided by the pressure. So we see that the gas is compressed to a volume of 7.5 liters and is heated to 350 kelvins. We want to find the new pressure. So let's plug in what we know. 7.5 equals 0.05 times the new temperature, which is 350, divided by the pressure. So 350 times 0.5, let's take care of that part first. 7.5 equals 0.05 times 350, which is 17.5 divided by pressure. We want to get pressure out of the denominator, so we're going to have to multiply both sides by P. So 7.5 times pressure, P, equals 17.5. And now we can just divide. Divide by 7.5 and divide by 7.5. When you do this in your calculator, you're going to get a pressure that is 2.3 repeating. But remember what 0.3 repeating really means. It means a third. So our pressure for this new situation is 2 1/3 atmospheres. Just like with strict direct variation and strict inverse variation, we can vary combined and jointly with things other than just x and y. We can have squares and square roots. So here we have y varying jointly as x and the square of z. So this generic equation is y equals k x z squared. Now we know a particular situation. We know y is 189 when x is 7 and z is 9. So let's plug in those values to find our constant. 189 equals k times 7 times 9 squared. So this means that 189 equals k times 7 times 81. So when we do 7 times 81, let's get your calculator out. 7 times 81 is 567. So we just have one last step before we get k by itself. We need to divide both sides by 567. And k equals another one of those repeating decimals. K equals 0.33333333. And since we want to get an exact answer, we want to make sure we write k as a fraction. In this case, 0.33333 repeating is 1/3. So our specific equation for this situation is y equals 1/3 xz squared. And again, once we have this specific equation, we can solve all sorts of problems about this particular joint variation problem. However, what we want to do is we want to find y when x is 12 and z is 5. So let's plug those values into our equation. Y equals 1/3 times 12 times 5 squared. This means that y equals 4 times 25. So y equals 100. How did I get 4 and 25? Well, 4 was 1/3 times 12, and 5 squared is 25. You could first do 12 times 25 and then divide it by 3, but you're going to wind up at the same answer. So combined and joint variation, just take what you already know about inverse variation and direct variation and just apply them to a little bit more complex situations or use them in the same problem.